Hey guys, welcome to my channel. My name is Lokesh and I work as lead architect. So let's continue our study. We are reading a book called AI Engineering, which is chapter 10 of this book. So let's continue from where we left off. And if you are new to this channel, I would strongly recommend that you start from playlist. I've already created a playlist. The idea here or the goal here is to learn together, learn AI together, and the fact that I'm making this content, it forces me to study more, to learn more, and this should have a reciprocative effect on you guys as well. So you should be able to get more knowledge as I study, and you can also do the same thing. You can also put out content and start studying as well. So with that, let's continue our chapter. So I think we had left at metrics last time around. So we discussed or the author is saying that metrics are important, but you should focus on the metrics which are like the north pole of a particular application. There could be a lot of metrics around an application, but you should focus on the one that is important, especially in case of AI Gen AI. Metrics like how many tokens are burned when you try to uh, query something, and how many tokens are returned when the query is executed. This particular token, number of tokens, is directly proportional to the cost that would be incurred. So this is one of those metrics which is important. So we should know about this. So let's study more on this. So now we are going to look at logs and traces. So let's read through. Metrics are typically aggregated. They condense information from events that occur in your system over time. They help you understand at a glance how your system is doing. However, there are many questions that metrics can't help you understand or answer. For example, after seeing a spike in specific activity, you might wonder, has this happened before? Logs can help you answer this. If metrics are numerical representations, measurements representing attributes and events, logs are an append only records of events in production or debugging process might look like. Metrics tell you something what went wrong 5 minutes ago, but they don't tell you what has happened. You look at the logs of events that took place around 5 minutes ago to figure out what has happened. Correlate the errors in the logs to the metrics to make sure that you have identified the right issues. So I think nothing out of the box here. If you have been working in IT, this makes sense. So logs are important, and logs are like read-only data that you keep on accumulating as and when you want. And maybe after a certain point in time, you might want to purge or delete out the old records or the old logs, so that is perfectly fine. And logs play an important part in identifying what happened, who caused it. I think who is basically something that I found in our projects important, because sometimes the production systems are not meant for the users which shouldn't have access. So that is where you can identify who initiated a particular event and what was the cause of an issue. For fast detection, metrics need to be computed quickly. For fast response, logs need to be readily available and accessible. If your logs are 15 minutes delayed, you will have to wait for the logs to arrive, okay? Because you don't know exactly what logs you'll need to look at the future. The general rule of logging is to log everything. Log all the configuration, including the normal API endpoint, model name, sampling, etc. Okay. Log the user query, the final prompt sent to the model, the output, and the intermediate outputs. Log if it calls any tool. Log the tool outputs. Log when a component starts, ends. Okay. So the author is suggesting log everything. So this might be important, but what could also be essential here is, do we know how to log all the activities that happen inside an application? Maybe you will some of the logs you'll be able to do it by out of the box features of the application. For example, usage of tokens, especially if you're using an endpoint, API endpoint. That particular information is available readily, but what if, you have to log some other things like who has logged in to the application, who is using the application, what are the intermediate results. So that is where you might have to do use custom logging. Let's read more. When recording a piece of log, make sure give give it tags and IDs so that help you from where this logs come from in the system. Logging everything means that the amount of logs you have can grow very quickly. Many tools for automated log analysis and log anomaly detection are powered by AI. When it is possible to process logs manually, it is useful to manually inspect your production data daily to get a sense of how users are using your application. Found that developers' perceptions of what constitutes good and bad output change as they interact with more data, allowing them to both rewrite their prompts to increase the chances of good responses and update the evaluation pipeline to catch bad responses. What is this hyperlink? Who validates the validators? Due to the cumbersome nature of human evaluation and limited large are increasingly being used to assist humans in evaluating. Okay, maybe this is some study or a white paper that has been done by someone in Cornell University. Maybe just let us just read more why the author has linked this particular article. When it's possible to process vector production data to get a flow of users and using found that the developer's perception changes as they interact with more data, allowing them to So I think this hyperlink is talking about as we get more information of the system, the perception of how the system is behaving changes, especially for developers. Due to cumbersome nature of human evaluation and limitation of code-based evaluation, LLMs are increasingly being used to assist humans. Okay, yet LLM generative will simply inherit all the problem. Yeah, that makes sense. Requiring further human validation will present a mixed initiative approach to validate aligning LLM. Our interface EvalGen provides automated assistance to users in generating evaluation criteria and implementing sessions. While generating candidate implementations, Eval asks human to grade a subset of LLM. This feedback is used to select implementations that better align with user grades. A qualitative study finds overall support for Eval but underscores the subjectivity and the identify phenomenon beta tracing. So I think they have introduced a new, maybe a tool called EvalGen, which helps in evaluation, or yeah, which helps in evaluation. I think that's all to it. But maybe to me, I think this article and whatever the author is saying here does not connect. I don't think they're talking about good and bad data, but maybe this is a white paper and you need to read more because it has comments. Yeah, maybe it's a white paper. That's okay. Let's read more. If logs are a series of disjointed event spaces are reconstructed by linking related events together to form a complete timeline. Okay, in short, a trace is the detailed record of a record's execution path through various system components. In AI application, tracing reveals the entire process from when the user sends a query. Okay. It should show how much time each step takes and its associated cost, if measurable. Ideally, you should be able to trace each query's transformation step by step through the system. If a query fails, you should be able to pinpoint the exact step. I think this is very typical. So you need to have especially in a data pipeline. You need to have the traces, like you'll have to do a drill down into your system to find out where and when the issue happened, especially if it's a data issue. So you will see whether the data issue exists in the primary source from where you're fetching the data, or it got introduced during your data pipeline. So I'm just taking an example. So I think the same logic would apply in case of the AI applications as well. So this might be an example of a trace. So this would help you identify how the error occurs. Okay, I think we have covered logs and traces, and we will continue with drift detection in the next video. Uh, and I hope this is useful. So just a reminder, guys, again, you need to follow the entire playlist to make sense of it. We are just covering chapter 10 of a book called AI Engineering by Chip Huan, and I hope you like this video. Although this has been a short video as compared to some of the other videos that we had, but I think we are down to some very small topics that I think we should devote only one session for it. So with that, thank you guys. I hope you have a good day, a good weekend, or a good week, but wherever you are, located. And if you find this helpful, please don't forget to subscribe. Thank you guys.